The reading should not have been there. Dr. Ilara Kessler stared at the neural topology display above Subject 11's body and felt the floor tilt under her boots. Every band had flatlined. Cortical beta, 0. Thalamic alpha, 0. Hippocampal theta, 0. 37 monitored frequency windows across the gray mental neural mapping array, and 36 of them presented the clean horizontal line of confirmed biological death. The 37th showed a steady, unwavering filament of activity oscillating at precisely 0.7 millivolts. She had verified death herself. Heart stopped 41 minutes ago, pupils fixed and dilated, core temperature already dropping past the threshold where cellular decay became irreversible. The Korathi medical examiner, a tall insectoid named Peel, had signed the termination certificate and left the chamber 20 minutes earlier. Subject 11 was dead by every clinical and legal standard recognized across 17 member worlds of the Vethani Compact. And yet, Ilara pulled her chair closer, the casters squeaking across the bright tiled floor of the consciousness mapping laboratory aboard Meridian Station. Daylight, or what the station's broad viewport panels admitted from the twin suns of the Athari system, flooded the room in clean white gold illumination, catching the dust motes that drifted above the body's chest. The gray mental array's holographic display hovered at eye level, translucent blue gridlines against the bright air, and that single thread of 0.7 millivolts pulsed with the steady rhythm of something that refused to acknowledge the absence of a living brain. She tapped the array's calibration panel, ran a full diagnostic. The system returned clean in 9 seconds. No sensor drift, no electromagnetic contamination from the station's power grid, no residual charge from the defibrillation attempts that had failed an hour ago. The 0.7 was real. She reached for her laminated access badge, a habit from her years at the University of Geneva before she'd taken the posting on Meridian and flipped it over. The back was covered in her own handwriting, threshold values, calibration constants, the shorthand she used when the holographic notepad was too slow for a thought that needed to land immediately. She found the line she was looking for. Consciousness threshold human, min detectable, 2.1 mV/VRIFIED across 6 studies. Below equals instrument noise. The reading on the display was 0.7, a third of the minimum threshold for detectable consciousness in a living human brain. Below instrument noise. Except it wasn't noise. Noise jittered. Noise wandered across frequencies. This was a clean, locked signal at a single frequency, and it had been holding steady for, she checked the timestamp log, 23 minutes, since 4 minutes after confirmed death. Ilara pulled her hands back from the display and sat very still. She was a consciousness researcher. That was the formal title on her compact credentials, and it was the reason she'd been recruited to Meridian Station 18 months ago, the only human on a team of 11 xenoneurologists drawn from 5 species. Her specialty was the boundary, the exact threshold where electrochemical activity crossed from mere cellular function into subjective experience, where the measurable became the felt. She had mapped that boundary in human brains, Korathi brains, Velasi brains, and the distributed neural webs of the Thaloni. In every case, the boundary was sharp. Below a certain voltage, there was nothing cellular machinery running on inertia. Above it, a mind existed. The lights were on. At 0.7 millivolts, the lights were off, had to be off. The literature was unambiguous. 6 peer-reviewed studies, her own name on 3 of them. She pulled up the waveform analysis and zoomed in. The signal wasn't just steady, it was structured. A repeating pattern buried in the 0.7, visible only at maximum magnification. A sawtooth oscillation with a period of exactly 1.3 seconds, modulating the base signal by plus or minus 0.04 millivolts. Like a heartbeat, like breathing, like something cycling through a rhythm that only made sense if you assumed the signal was carrying information. Her throat went dry. She tapped her comm badge. "Peel, come back to Lab 7. A pause. The Korathi examiner's voice came back clipped and mildly annoyed. "Subject 11 is certified. I have 6 autopsies queued." "Something still reading." A longer pause. "Define something." 0.7 millivolts. Single band. Structured waveform. It's been holding for 25 minutes. She heard the click of his mandibles, the Korathi equivalent of a slow blink. "Instrument error." "I ran the diagnostic clean." "Then sensor contamination." "Peel, I've been mapping consciousness thresholds for 9 years. This signal is structured. It's not contamination." Another mandible click sharper. "I will come. But I am telling you now, Dr. Kessler, the subject is dead. I verified that myself. Whatever your machine is reading, it is not consciousness." He arrived 4 minutes later, his exoskeletal frame filling the doorway as afternoon light from the viewport striped across his thorax. He crossed to the display, bent his compound eyes toward the holographic waveform, and stood motionless for 11 seconds. "You see it," Alara said. "I see a signal that should not exist." His voice had lost its annoyance. "This is not a known post-mortem artifact. Korathi bodies produce residual neural discharge for up to 3 minutes after death. Humans produce none. 0. Your species' neurons depolarize completely." "I know." "Then this reading is either an error in your equipment that your diagnostic cannot detect, or it is something we have never documented." He straightened. "I will get Dr. Vasic." Vasic was the station's chief xenoneurologist, a Velisi, a species that looked roughly like a 2-meter-tall otter with 4 arms and eyes that shifted color based on cognitive load. When she arrived, her eyes were a calm amber. By the time she'd studied the display for 90 seconds, they had shifted to a deep indigo that Alara had never seen before. "This is not post-mortem discharge," Vasic said quietly. "The structure is too organized, and the frequency, look." She manipulated the display, overlaying a standard consciousness mapping grid. "If this signal were at 2.1 millivolts or above, it would map to a pattern I recognize: low-level ambient processing, background monitoring. The kind of activity a brain produces when it is not thinking about anything in particular, but is still present." "But it's at 0.7, Alara said. "A third of threshold." "Yes," Vasic's eyes deepened further, "which, in every model we have, means it cannot be consciousness. Unless our model is wrong." The words landed in the bright, sun-flooded laboratory like a stone dropped into still water. Peel's mandibles locked. Vasic's eyes went so dark they looked black. "Explain what you mean," Vasic said. Alara stood up. She walked to the body, a human male, mid-50s, a station maintenance worker named Gregor Hahn, who had collapsed from a cerebral hemorrhage during a routine shift change. She had known him slightly. He'd fixed the water recycler in her quarters twice and left behind a faint smell of machine oil and peppermint. Now he lay on the mapping table in the clean light, his face slack, his hands folded across his stomach by someone who'd cared enough to do that before leaving. "I mean that every consciousness threshold study, mine included, was conducted on living subjects," she said. "We measured the minimum voltage at which subjects reported subjective experience. Below that threshold, they reported nothing. So we drew the line there, but we drew the line based on what subjects could report, not based on what was actually happening." "You are suggesting consciousness exists below the reporting threshold," Peel said flatly. "I'm suggesting we've never been able to test for it, because we relied on subjects telling us when the lights were on. And the lights might be on at a level so low that the subject can't tell us they're seeing anything." Vasic's 4 hands gripped the edge of the display console. "Dr. Kessler, If consciousness exists below 2.1 millivolts, below the level at which any brain can generate a report, then we have no way to confirm it exists. By definition, it is unfalsifiable. Unless you look at a dead brain, Alara said, and find it still running. The silence held for 8 seconds. Then Vasek said, "Show me the full waveform analysis, every band from the moment of death." Alara pulled it up. The playback began at the moment of Gregor Hahn's cardiac arrest, 61 minutes ago. The display showed all 37 frequency windows collapsing in sequence, a cascade of neural shutdown that followed the textbook pattern for human cerebral hemorrhage. Beta waves dropped first. Alpha followed. Theta lingered for 11 seconds, then fell. Within 40 seconds of cardiac arrest, every band was at zero. Except one. The 37th window, an obscure monitoring channel that tracked ultra-low frequency oscillations in the cortical substrate, a band so low energy it was usually dismissed as baseline calibration noise, showed a brief dip to zero at the moment of cardiac arrest, then a recovery. A slow climb from 0 to 0.3 millivolts over the first 2 minutes, then 0.5, then, at the 4-minute mark, 0.7, where it stabilized. And stayed. "It recovered," Vasek whispered. "After death," Peel said. His compound eyes reflected the display. "The brain died and then something in it restarted." Alara flipped her badge over again. The threshold numbers stared back at her in her own handwriting. 2.1 millivolts, verified, below equals noise. She put the badge down. "I need to run a pattern correlation analysis," she said. "If this signal is structured, if it's carrying information, then I can compare it against known cognitive templates, not to prove its consciousness, just to see if the structure matches anything we've cataloged." "Do it," Vasek said. The analysis took 4 minutes. Alara fed the 0.7 millivolt signal through the Graymental's pattern library, a database of over 14,000 cataloged neural signatures drawn from 8 species, and representing everything from deep sleep to peak cognitive engagement. The system compared the unknown signal structure against every template in the library, looking for statistical correlations above the 0.3 threshold. The result came back with one match, correlation coefficient 0.91. The match template was labeled Human Resting Awareness, EYES closed, relaxed but alert. Alara read it twice, then a third time. "He's aware," she said. The words came out flat, stripped of inflection, because inflection would have required her to decide what she felt about saying them, and she was not ready for that yet. "The signal matches the pattern of a human brain in relaxed resting awareness, eyes closed, alert. The correlation is 0.91. Peel stepped back from the table. It was a small movement, but Alara noticed it. The first time she had ever seen a Korathi medical examiner retreat from a body. "He has been dead for over an hour," Peel said. "Yes." "His heart has not beaten in over an hour." "Yes." "His neurons have fully depolarized. The cellular machinery has stopped. There is no blood flow, no oxygen delivery, no metabolic substrate for consciousness to operate on." "I know." "Then what is generating the signal, Dr. Kessler?" She didn't answer because she didn't know. Instead, she did what she had been trained to do for 9 years. She gathered more data. She reconfigured the Graymental array for deep structure mapping, a mode that consumed 3 times the normal power draw, but allowed visualization of neural topology at the subcellular level. The array projected a 3-dimensional holographic model of Gregor Hahn's brain into the air above his body, rendered in translucent blue with active areas highlighted in white. The brain was dark, all of it, dead tissue rendered in a uniform slate blue that matched every post-mortem scan Alara had ever seen. Except for one thread. A single filament of white light, thinner than a hair, traced a path from the brainstem through the thalamus and into the prefrontal cortex. It followed no known neural pathway. It didn't correspond to any fiber tracked in the anatomy textbooks. It simply existed, a luminous line drawn through dead tissue, connecting regions that had no anatomical reason to be connected, pulsing with the same 1.3-second rhythm she'd identified in the waveform. Vasek made a sound Alara had never heard a Velisi produce, a low, sustained vibration from her secondary vocal cords that translated, roughly, as the sound one makes when a foundational assumption collapses and the floor hasn't been found yet. That pathway does not exist in human neuroanatomy, Vasek said. No, it does not exist in any neuroanatomy I have studied across 31 years and 8 species. No, it is generating 0.7 millivolts of structured, pattern-matched activity in a brain that has been dead for, she checked the log, 68 minutes. Yes. Vasek turned to face Alara directly. All 4 hands were pressed flat against her sides, a Velisi posture of extreme focus. Her eyes were black. Dr. Kessler, in your professional opinion, is Gregor Hahn conscious? Alara looked at the body on the table, at the folded hands, at the slack face lit by twin-sun daylight, at the holographic thread of impossible light tracing its path through a dead brain. In my professional opinion, she said, the word conscious was defined by people who assumed it stopped when the heart did. We built our instruments to measure what we expected to find. We set our thresholds based on what living subjects could tell us. And none of it accounts for what I am looking at right now. That is not an answer. No, it's the reason I don't have one yet. She turned back to the display and began isolating the signal's information content. If the 0.7 millivolt thread was carrying structured data, if the pattern correlation wasn't a statistical artifact, then the data could, in theory, be decoded. Not as language, not as thought in any way the word was conventionally used, but as pattern, as structure, as the architecture of whatever was happening inside a dead brain that had decided, against every known law of neuroscience, to keep a single light on in an empty house. The decoding took 17 minutes. During those 17 minutes, Peel returned to his autopsy cue but came back twice to check the display. Vasek stood motionless, all 4 arms folded, eyes fixed on the thread of light. 3 other team members, a Korathi neurochemist named Esh, a Thaloni distributed cognition specialist whose name was an untranslatable harmonic, and a human neural interface engineer named Tors, arrived after Vasek sent a priority flagged data packet to the full team. They stood in a loose semicircle around the mapping table, watching as Alara worked. She had forgotten them. She had forgotten the station. She had forgotten the twin suns and the bright laboratory and the fact that she had not eaten in 7 hours. She was inside the data the way she had been inside data 4 times in her career, the moments when the instruments showed her something that shouldn't exist, and the only correct response was to keep looking until the shouldn't became a did. The decoder returned its results at the 68-minute mark. The 0.7 millivolt signal was not random. It was not noise. It was not a post-mortem artifact. It was a repeating data structure with a consistent internal grammar, a pattern language built from the sawtooth oscillations, organized into hierarchical clusters that resembled nothing in the gray mental's template library but were, unmistakably, organized. And the structure was changing. Not degrading, not dissipating, changing. The hierarchical clusters were reorganizing themselves in real time, slowly, like a plant growing toward light. The pattern was restructuring its own architecture at a rate of approximately 1 modification every 90 seconds. It's learning, Tors said. He was standing behind Alara now, reading over her shoulder. His voice was very quiet. Whatever this is, it's adapting. It's responding to something. Responding to what? Esh asked. The Korathi neurochemist's mandibles were half open, an expression Alara had learned to read as deep unease. "I don't know," Tors said, "but organized adaptive restructuring doesn't happen in isolation. It requires input. Something is feeding this signal information, and the signal is processing it." Alara's hands went still on the console. She looked at the holographic brain model, at the single thread of light running through dead tissue. Then she looked at the gray-mental array itself. The ring of 64 sensor nodes arranged in a crown above the body's head, each node actively emitting a low-power scanning pulse to map the neural topology. Actively emitting. "Turn off the array," she said. Vasik's eyes shifted. "If you turn off the array, we lose the data. Record everything first, then power down the scanning pulses. Leave the passive receivers on." "Why?" "Because the array is emitting a scanning pulse every 0.8 seconds, and the signal's sawtooth oscillation has a period of 1.3 seconds. If the signal is responding to the array, if our instrument is the input, then turning off the scanning pulse should change the signal's behavior." Tors understood first, his face drained of color. "You think the array is having a conversation with it?" "I think we built an instrument to measure consciousness, pointed it at a dead brain, and something in that brain started talking back." The words fell into a silence that pressed against the walls. Daylight poured through the viewport. Dust motes drifted. Gregor Hahn's body lay motionless on the table, hands folded, face slack, the thread of impossible light still pulsing through his cortex. Vasik gave the order. Esh recorded the full data state. Tors powered down the array's active scanning pulses, leaving only the passive electromagnetic receivers online. The 0.7 millivolt signal held steady for 4 seconds. Then it began to climb. 0.8091.1. The sawtooth oscillation tightened. The period shortened from 1.3 seconds to 0.9, then 0.7. The hierarchical clusters in the decoded data structure reorganized themselves faster, one modification every 30 seconds instead of 90. New clusters appeared, structures that had no template match, no precedent, no name. "It's accelerating," Vasik said. "You removed the scanning pulse, and it accelerated." "The scanning pulse was constraining it," Alara said. She could hear the edge in her own voice and did not try to suppress it. "Our instrument was holding it at 0.7. It wanted to go higher. We were the bottleneck." The voltage hit 1.4 millivolts, then 1.8. The thread of light in the holographic brain model thickened, branched, sent delicate filaments into regions of the brain that had been dark for over an hour. Each filament flickered white for a fraction of a second, then stabilized. At 2.1 millivolts, the exact threshold she had written on the back of her badge, the number she had verified across 6 studies, the line she had drawn between noise and consciousness, the signal's structure underwent a phase transition. The hierarchical clusters collapsed into a single unified pattern that bore a 0.97 correlation to the gray mental's template for human, active focused attention. Gregor Hahn was paying attention. His heart had not beaten in 74 minutes. His lungs had not drawn breath. His blood had pooled and begun to settle. But the thread of light in his brain had crossed the threshold, and the pattern said, "Someone is here. Someone is paying attention." "This is impossible," Peel said. Alara did not answer him. She was watching the display. The voltage was still climbing. 242.7, 3.1. Each increase brought new pattern matches, templates for alertness, orientation, spatial awareness. As if the signal were bootstrapping an entire mind from a single thread, building a cognitive architecture from the ground up in the ruins of a dead brain. At 3.6 millivolts, the pattern matched human recognition. At 4.1, it matched human, intentional directed search. At 4.8, it matched a template Alara had cataloged herself, years ago in Geneva, from a subject who had been asked to solve a complex spatial puzzle while under full neural mapping. The template was labeled, "Human, Problem-Solving Under Constraint." The dead man's brain was trying to solve a problem. "What is the constraint?" Tors asked. His voice was barely audible. Ilara pulled up the spatial analysis of the thread network. The filaments had spread throughout most of the cortex now, a web of white light in dead tissue, but they were concentrated most heavily in two regions: the prefrontal cortex, where the problem-solving template was seated, and the motor cortex. The motor cortex, where movement originated. "The constraint," Ilara said slowly, "is that he can't move." She heard Tor's breathing change beside her. Esh's mandibles clicked shut with a sound like a closing lock. Vasik's secondary vocal cords produced that low vibration again, longer this time, sustained, the sound of a worldview fracturing. Gregor Hahn's brain dead for over an hour, running on a signal that no textbook acknowledged, powered by a mechanism no one could identify, was trying to move his body. And failing. And trying again. And failing. The problem-solving template cycled and recycled, approaching the motor cortex from different pathways each time, probing for a route that worked, finding none, adapting, trying again. Ilara's hands were shaking. She pressed them flat against the console and held them there until they stopped. "We need to communicate," she said. "How?" Vasik asked. "The signal responded to our scanning pulse. It adapted to it. If I modulate a low-power M pulse with a structured pattern, something simple, a binary framework, and direct it at the thread network, the signal may respond." "May," Peel said, "or may be disrupted entirely. We do not know what is sustaining this. If you interfere with it." "If I do nothing, I watch a dead man's brain try to move a body it can't move, indefinitely, while we stand here cataloging the phenomenon." She looked at Peel. "I won't do that." Peel's compound eyes held hers for 3 seconds. Then he stepped back, not retreating this time, yielding. Ilara configured a single sensor node to emit a modulated pulse, a simple repeating binary pattern. On-off, on-on-off, off-on. 7 elements, arbitrary. The smallest possible handshake, just enough structure to say, "This is intentional. This is not noise. We see you." She activated the pulse. The 0.7 millivolt signal, now running at 5.3 millivolts, far above any threshold, the thread network blazing white through the holographic brain model, responded in 4 seconds. The sawtooth oscillation interrupted itself, held flat for 2 full cycles, then produced a modulated burst that exactly mirrored the structure of Ilara's binary pattern. On-off, on-on-off, on. Esh stepped back from the table. Tor's hand found the edge of the console and gripped it. Vasik closed all 4 of her eyes, something Ilara had never seen her do, and opened them again. Ilara's chest hurt. She realized she had stopped breathing and forced herself to inhale. "He heard us," she said. She modified the pattern, sent a new sequence, longer, 12 elements, a different structure. The signal reproduced it in 3 seconds. She sent a third pattern embedded with a mathematical progression, 1, 1, 2, 3, 5, 8, Fibonacci. The signal reproduced the sequence, paused for 1 full cycle, then extended it. 13, 21, 34. "Oh God," Tors said. Ilara's hands were steady now. The shaking had stopped. In its place was something she recognized from her years of working at the boundary, the absolute clarity that came when the data left no room for interpretation, and the only question remaining was what to do about it. She sent a longer pattern, a structured query built from nested binary clusters, designed to map the signal's self-model. In plain terms, she was asking, "What do you think you are?" The response took 19 seconds, the longest delay yet. When it came, the data structure was unlike anything the gray mental had ever recorded. It wasn't a neural template. It wasn't a cognitive pattern. It was a topological map, a three-dimensional structural representation that, when Alara rendered it holographically, showed a shape she recognized. It was a map of the thread network itself. The signal was showing them its own structure. It was saying, I am this. This is what I am. And at the center of the map, rendered in a different modulation from the rest, was a single point, the origin node, the place where the thread had first appeared in the brainstem, 4 minutes after Gregor Hahn's heart had stopped. It knows where it started, Vasek said. Her voice was rough. It knows what it is, Alara corrected. It has a self-model. It can represent its own structure to an external observer. That's not awareness. That's self-awareness. She sat back in her chair. The twin sunlight had shifted as the station's orbit carried them around the primary. The light was warmer now, late afternoon gold pouring across the laboratory, catching the holographic display and throwing rainbow refractions across the ceiling. Dust motes turned in the light. The body on the table was still. The thread network blazed. We need to talk about what this means, she said. It means your instruments have been wrong for 9 years, Peel said. There was no accusation in his voice, only the flat statement of a clinician recognizing a misdiagnosis. Not wrong, incomplete. She picked up her badge again, looked at the threshold number on the back, 2.1 millivolts, the line she had drawn. The line everyone had drawn, across 8 species and 14,000 cataloged signatures, the foundation of consciousness science across the compact. We measured the threshold of reportable consciousness, the point at which a brain can tell us the lights are on. We assumed that was the same as the threshold of consciousness itself, but it isn't. You're saying consciousness exists below the reporting threshold, Torres said, in everyone. I'm saying this signal was running at 0.7 millivolts in a dead brain, and it was coherent and organized and present. In a dead brain. If it exists at 0.7 in a dead brain, where does it exist in a living one? At what voltage does it actually begin? And if it begins lower than we thought, Vasek said slowly, then the termination threshold is also lower than we thought. The termination threshold might not exist, Alara said. Not the way we defined it. Gregor Hahn's neurons depolarized. His cellular machinery stopped. His brain, by every measure we used, died, and something in it kept going, not as a residual, not as an echo, as an adaptive, self-aware, communicating signal that our instruments couldn't detect because we'd set the threshold too high. The silence this time lasted a long time, 30 seconds, a minute. The suns moved, the light changed. How many? Esh said finally. The Korathi neurochemist's voice was barely above a whisper. How many subjects have we across all our studies, across all species? How many have we certified as dead and cremated or processed, or he stopped, his mandibles locked? All of them, Tor said. The answer is all of them. Ilara stood up. She crossed to the Greymental's control interface and began recalibrating the array. Not for Gregor Hahn. His thread network was already being monitored passively, the signal still climbing, now at 6.2 millivolts and still producing new pattern matches, still building, still learning, still there. She was recalibrating for the general case, adjusting the detection threshold from 2.1 millivolts down to 0.1, widening the frequency windows, opening the instrument to the range it had been designed to ignore. What are you doing? Vasek asked. Building a detector that can see what we've been blind to. She didn't look up from the console. If this signal exists in the dead, it exists in the living. And if it exists in the living, we need to know what it is, how it works, and what happens to it at every stage, including the stages we've been calling death. The Compact's medical protocols are built on the current threshold, Peel said. Every certification of death, every allocation of life support, every decision about when to stop resuscitation. If you publish this, then every one of those protocols was built on incomplete data, and they need to be revised. She looked at him. How many patients have you certified, Peel? His mandibles opened and closed without producing sound. How many have I certified, she said, in 9 years of consciousness research? How many subjects did I measure, draw my line, and walk away from, while something at 0.7 millivolts was still running in their heads, trying to move, trying to reach out, trying to make us hear? She could not answer that question. She could not answer it because the instruments she had trusted for 9 years had told her there was nothing to hear, and she had believed them, and the number of subjects she had certified was a number she could not hold in her mind without the floor tilting again. So she did the only thing she could do. She finished the recalibration. She saved the new detection parameters. She documented Gregor Hahn's signal. Every millivolt, every waveform, every pattern match, every impossible moment of a dead brain saying I am here, in a file that would become the most accessed dataset in the Compact's scientific archive. And then she did the thing that mattered most. She turned back to the modulated pulse interface. She composed a new signal, not a test pattern, not a mathematical probe, not a structured query. A simple, sustained, low-power pulse modulated with the binary pattern for a single concept that the gray mental's translation matrix could encode across species. The concept was, we know you are here. She sent it. The thread network flared, every filament brightening simultaneously, the holographic brain model blazing white from brainstem to cortex, the voltage spiking to 8.1 millivolts for a fraction of a second before settling back to 6.4. The sawtooth oscillation smoothed into a long, slow wave that the pattern library matched, at 0.94 correlation, to a template Alara knew well. Human relief. She stayed at the console. The twin suns set behind the station's horizon, and the laboratory's overhead panels adjusted to maintain their bright, clean illumination. Tors brought her coffee from the commissary. Vasek began drafting the data integrity report that would accompany publication. Peel returned to his autopsy queue, then came back an hour later and asked, very quietly, if Alara could recalibrate his own examination equipment before he certified another death. She did. She recalibrated his equipment and Tors and Esch's portable neural scanner and the 3 monitoring stations in the station's medical bay. She lowered every threshold. She widened every window. She opened every instrument on Meridian Station to the range it had been designed to ignore, and by midnight, 16 hours after Gregor Hahn's heart had stopped, the station's entire medical infrastructure could see what it had been blind to. 7 of the 11 team members stayed in Lab 7 through the night, not because anyone ordered them to. Because the signal was still there, and it was still climbing, and they had all spent their careers measuring consciousness without realizing they'd been measuring only the part of it that could shout loud enough to be heard. The quiet part, the part that ran at 0.7 millivolts in the dark, in the silence, in the space after the heart stops and the instruments say 0, the quiet part had been there all along. Gregor Hahn's thread network was still active when Alara finally sat back from the console, 21 hours after his death. The voltage had stabilized at 7.8 millivolts. The pattern matches now included templates for sustained attention, environmental awareness, emotional processing, and the one that made Tors turn away from the display and stand at the viewport for a long time, looking at the stars, human gratitude. Alara looked at her badge, at the threshold number written on the back in her own handwriting, 2.1 millivolts, verified across 6 studies, below equals noise. She uncapped a pen, drew a careful line through the number and wrote beside it in small steady letters, wrong. Then she put the badge face up on the console so the number wouldn't show, and turned back to the signal. The signal that had been waiting, below the threshold, below the noise floor, below everything they had built to see, waiting for someone to lower the instruments enough to hear it say the only thing it had ever been saying. Still here. She pressed her palm flat against the console, centering herself. Outside the viewport, the twin suns were rising again, flooding Lab 7 with clean white gold morning light. The dust motes caught the light. The holographic brain model glowed, and somewhere inside a body that every instrument in the compact had declared dead, a thread of 0.7 millivolts, patient, quiet, persistent as bedrock, held its ground. Still here. Still here.